and let's do a cosmology segment. Like I said, folks, lots of stuff to cover today. So today's cosmology segment will feature a few different things. First of all, let's talk about our mission. You can find the rest of our mission at smashamash.com/forum/mission. smashamash.com/forum/mission. You can link to that on the homepage as well. Number 5, to publish scientific papers in a multidisciplinary manner, including but not limited to science such as spectroscopy. Notice how that's the first thing on the list, folks? Spectroscopy. Also chemistry, astrophysics, health, wellness, longevity, cosmology, biology, magnetohydrodynamics, geology, etc. Why am I stressing the word spectroscopy? Well, because some people seem to agree. Now let's talk about the way that gravitational waves affect dark matter. Gravitational waves are waves that are created through gravity, and we're able to detect them using LIGO all the way from Earth, because when neutron stars and black holes merge with each other and other stars orbit each other, like you're seeing here, they create ripples through the space-time reality, and then gravity gets warped, and we can test them using laser interferometry. Just kidding, folks. There's a new Sky Scholar video, which is entitled The Most Important Tool in Astronomy, Analysis of Spectroscopic Lines. Yes, folks, it's true. The most important tool in astronomy, analysis of spectroscopic lines. Now, I would tend to agree. Now, I used to think radio astronomy was boring, but people like astronomy professors in the mid-90s informed me that radio astronomy is the future of astronomy, and it's far from boring. Well, it turns out that it's all too true. I kind of believed them back then. I just didn't understand the physics of why. Well, I currently understand the physics of why, and so does Robitaille. So here is a little tiny clip of a video I haven't even watched yet, because we've been so busy with, well, things that you may already know about if you watch our other videos. But in any case, here's a tiny blurb from Sky Scholar, aka Pierre-Marie Robitaille, regarding analysis of spectroscopic lines.
Note that now we are talking about the broadening of the spectral line, not its shift. Doppler line broadening is caused by random thermal motions of atoms.
And I'll just leave it there to play you a teaser so that you watch the video. We'll share this as a community post later today. Make sure you subscribe to Sky Scholar and watch all of the videos. And next we're going to go into a random number. So random number between 1 and 1031 will coincide with some object over at the Neil Gorell Swift-Bat X-ray Observatory. Today's object is entry 358. And what might 358 be, you ask? Well, you don't have to ask, because I'll ask. 358 is 4C01.28, a quasar, which will probably look like a single point of light. First, let's look at the X-ray emission spectra, the transient X-ray outbursts from this quasar, and there it is. By the way, if you have a galaxy, let's say you have a galaxy that's looking kind of warped like this, you're looking at it not directly down the polar field, right? You're looking at it from an angle. When you're looking at a galaxy from an angle, there's a polar jet that comes out of the galaxy's core like this, in many cases perpendicular to the disk of the galaxy. If you're looking at the galaxy from this sort of a perspective, the galaxy looks very bright. That is what we call a quasar, or perhaps a blazar. If you're looking at it sort of from this orientation, it'll be what we would call an active galactic nucleus. And if you're looking at a galaxy and it just kind of looks like this, with a little bulge in the middle sometimes, that's most likely going to be a radio galaxy. And it all has to do with perspective. This one is a quasar. Probably looks like a single point of light. Let's see if my forecast comes true. Anyway, there are the X-ray transients. We actually saw some major transients out of it. And this one is completely off of the scale. That one might actually warrant some further study there, as it's almost all the way up to 0.3, where this scale only goes to 0.03. This outburst right here is well off of the historic chart, as you can clearly see there. Let's see what else is going on with 4C 01.28. It'll look like a single point of light on Aladdin. And there you can see that quasar, and that's because, once again, you're looking directly down the polar field, which makes these galaxies look very bright and obscures them because of the nature of the material being emitted from its core. So here it is in the 2 mass. Let's take a look at it on blue light. There it is in blue light. It's looking pretty symmetrical there, an indication that we're probably quite centered on the polar field of that. Here it is on Chandra. You can see it's a very, very bright X-ray source. And perhaps this is giving us some insight into the orientation of its galactic disk. As you can see, this series of line-like data points. See if it shows up on XMM Newton. And there it is on XMM Newton. Quasar 4C 01.28, today's recently active quasar. And that's today's